Okay, let's go ahead and get started. Hi, welcome to my tour of GNU Guix. I'm Jack, and I'll talk at you for the next half hour or so. First things first, what is this thing I'm going to be talking about? Let's start with the pronunciation. It's pronounced geeks, like the English word geeks. I'm going to be saying it a lot, so let's get comfortable with that. It has a large community in Europe, and I think that's where the name originated. And so perhaps I've run into a lot of English speakers who that's not the first pronunciation they come up with. That's an explanation for perhaps why that is, or perhaps not an explanation, but interesting fact nonetheless. But what is it? It's a member of the GNU project and is a Linux distribution and package manager. What does it mean to be part of the GNU project? I expect many of you here know, but one of the first free software projects at the time to write a complete operating system that would be free of proprietary restrictions. Since then, the world has changed a little bit. In some ways, GNU has been a wild success. But thinking about what I want to do with software freedom now, perhaps there's still a ways to go. I think we have a keynote sometime at this conference also about that. But there's perhaps more free and open source software now than there ever was. But still, I struggle with actually being able to use software freedom everywhere I'd like to. So Geeks is happening in this context of what it means for the GNU project now. And one of the things it means to be part of the GNU project as opposed to a distribution that is separate is that it can work in harmony with other aspects, other software projects that are part of GNU. The one it's most closely associated with is Guile, GNU's ubiquitous intelligent language for extensions, a scheme dialect. That's what Geeks is implemented in, and what a lot of my interactions with it are through the programming interface, which is also in Guile. But it integrates with GNU's init system, Shepherd, their cron package, and also GNU Mez we'll talk about a little bit later. It's a bootstrapping project. And of course, the standard things, the compiler, the C library. But for Geeks to be part of GNU in this context, it can work in harmony to build a better GNU, but also to advance some social goals about bringing software freedom to people instead of just for the developers. So now I've said software freedom. All right, so this is perhaps in slightly different words the official 4 freedoms that the FSF says. The problem I have with this is that they're true, but a little bit vague. It doesn't tell me what I need to know when I'm writing software or I'm using software. Yes, I'd like to be able to run it as I wish, but what does that mean? How do I go about that? Distributing software is great. There are lots of ways to do it. How can I do it best to advance software freedom and not just get the job done? And part of the problem is software is complicated. This is a quotation from Bradley Kuhn's blog post where he's reflecting on how important Debian was to him. He woke up and saw Debian running on his laptop and had the nice lock screen and thought, I've really had a positive experience with Debian. And that is, Debian has provided him, who can't be an expert in everything, different programming languages, parts of the system that interact with expertise. So in some ways, this is an argument for the value of distributions. But so Debian is great, but it suffers from some things. As a user, if I wanted to exercise some software freedom, perhaps running software as I wish, maybe I need to change it for that to happen. Well, the process in traditional distributions like Debian and Fedora, To build a new package, I either use the official build infrastructure or something like PPAs, which is this entire software stack set up to build and deploy packages, or I build it locally using pbuilder or some additional software I have to set up. And these large projects also have a lot of social programs for how to get people to work together in a coordinated way so we don't break the distribution. There's a reason that we've developed these complex solutions to this problem, and I claim that it is state. One of the other things that I have liked to do in the past is do some Haskell programming. And spending this time in a functional programming community probably has nothing to do with why this message about state resonates so much with me, but that state is hard to reason about. It makes things fragile. I think this is the same problem that containers are solving, in that it's breaking up the global state into smaller pieces. Another practical problem is these single language package managers or just works, things like pip and Anaconda and npm and bundler and Ruby gems. That's great, and they work in their little part of the world for their language, but when I have to go outside that, so at work at Duke University Libraries, one of our projects is an online app for archiving 3D samples. So instead of going to a museum to look at fossilized primate skeletons, you might instead go online and download an image, a 3D image, which saves you a trip. Also, these are fragile. So this involves our standard repository web app, which is a Ruby on Rails app, but also involves C++ software for dealing with 3D images, something new for us. We couldn't do this all with the Ruby just works, take this file and give me my Ruby dependencies thing. So in that way, it's not bridging the gap between the different parts of the world. OK, so I claim that Geeks help solve some of these problems. But how is that? So what makes Geeks different allows it to attack the state problem that a traditional distribution wouldn't. So in a traditional distribution that follows the file system hierarchy standard, you get one global namespace. You install all your programs, and they write to the same global directories. The executables go in bin, the libraries go in lib, configuration goes in etc. Geeks doesn't do that. Everything that Geeks manages goes in one location called the store, but inside that, it manages in such a way so that packages each end up with their own namespace. So let's take a look at this. But first, the store is managed by the Geeks daemon. So the way you interact with the system is you send a derivation to the Geeks daemon. So on line 3, we see amongst this is a sampling of items I had in my store when I was preparing this presentation. So by default, it's located a new directory on the system, GNU store. And line 3 is this drv file. That's a derivation. So this was a build instruction that I have sent to the store, to the Geeks daemon, which put in the store and then operate on it. And so follow the instructions in the derivation to create something else. It could have been the Emacs package, which has its own namespace, or the pwgen package. But it's not just packages at the end of the store, anything that Geeks operates on. So single files, this patch file, which is part of the source used to build something else, a cron job, all end up in this place that allow Geeks to operate on programmatically. So let's take a look inside one of these store items. So this is a view inside the Emacs package, somewhat abridged, but it has what you expect. It has a bin directory with 6 executables: Emacs client, Emacs server, etags, Emacs itself. Also, the libraries. Emacs ships with a systemd unit for starting the Emacs server on distributions that use systemd, so that's in there. So that's great, but now I have this one. It seems like it's still a global namespace. It's not mixing everything in bin and etc, but I have this global namespace, which is GNU Guix. How does that help? Well, I'm going to create slices into it. So I can instruct geeks that I like a slice into this global namespace, and the only part of it I want to see is the packages hello, which is GNU's example package for how to use do standard things like use auto tools and print out hello. It's great for examples. The Emacs package that we just talked about, and this neat little game, make everyone happy, cow say, print out your text with a little ASCII art cow. So I've asked Geeks to do that, and what has it given me? It's given me the symlink farm, which just has what I need in it. So I look at this. Well, so far, the only thing I see is symlinks for Emacs. What about those other two packages? It turns out that include and libexec are only provided by the Emacs package. And if we do a deeper dive into the bin directory, there are those other packages. So Geeks has created me this little slice, which in this case I put in temp, into the store. So here I've restricted my global state to just the packages I want. So I can do this for any number of things. Each user can have their own slice into the store. Each user can have multiple slices into the store, etc. So there have been a lot of ellipses in these slides. What am I hiding? Well, I'm hiding another feature of Geeks, which are these hashes. It prevents a little bit of a printing problem on the screen, but also this additional complexity means something else. Every store item in Geeks has its dependencies tracked. So when I built the GNU Hello package, it depended on my C library, my C compiler, my auto tool setup, and also the build recipes for that package, amongst other things. All those are hashed, and so they're stored in the store prefixed with their hash. What this means is that I can have multiple copies of the same thing, but that vary in a different way. Maybe the dependency changed. Maybe I've changed the build instruction to suit my needs. I don't have to choose between the old version and the new version. I can have both present on my system and call them up in different views in the store as I want. So in this example, we look at something else that's not a package, the grub configuration for booting the system. And why do I have multiple ones of these? Well, it's not just for these views into the store are not just things I create when I want to. Everything is described in terms of these. So when I boot my system, my boot configuration and my Linux command line tell it to load the set of packages that it has available system-wide as a view into the store. So when I upgrade the system and reconfigure it, I get a new grub configuration that points to that new view. If I wanted to, at the grub menu, the old ones are present. I could go back into my old configuration if I broke something or if I liked it better for whatever reason. So how do I create these things in the store? There's the Guile programming interface that we talked about. So let's look at perhaps the most common one of that, and that's defining a package. It's not the only one, but in everyday life, it's one of the ones that's most useful. So the example I'm using is something that's not present in Geeks because it's only important to my local environment. It's a little wrapper script for SCP that I use at work to do some of our extra multi-factor stuff for me. If you're not familiar with Scheme, it's a dynamically typed programming language, supports multiple paradigms. In Geeks, they try to use it in a mostly functional style. It's lexically scoped. In this first part of the package definition, it's a scheme record, which is key value mapping. So we have the name, the version of the package, the actual SCP wrapper is not that long, so I've put it up just as a snippet on our code hosting site. Perhaps I should have put it in something that would track its versions better, but this was a quick hack that I was doing. Fortunately, Geeks will track the checksum of that and will yell at me if it changes, and then I know to fix it, so it won't silently fail. Okay, where's the build instructions? Geeks has a library of different build systems. In this case, I've used the trivial build system, which does nothing for you. In most of the package you'll find in Geeks, they'll use one of the prepackaged build systems, and so it will be less verbose. But this allows us to see a little bit more of the steps. So the build system is a Guile Scheme program that gets past the daemon that runs. The library abstraction has different stages for stage unpack, configure, build, test, install. In my case, I don't need to do too much, but there's some setup to do. As I said before, Geeks tracks the inputs. They're used to build the store items. So in this case, in the let on line 7, essentially what I'm doing is binding names to values. So the source location is some path in the store. I'm doing this programmatically because I don't know while I'm writing the package what the hash is. It's based on the downloader and the checksum of the file. But I can take that name and bind it to the source. This is an SCP wrapper written in bash, so I also need SSH and bash. So this is how I build my script. And how I avoid depending on a global namespace. If I were to run this script on a Debian box, I'd probably just shell out to SSH and let the shell figure out which SSH I want. That depends on SSH being visible in that global environment that the script's running. What if I had modified SSH in a made-up example in my global in the environment where I type in commands to do other stuff I'd like, but I don't want this script to pick up that one because it doesn't work because the modification I made was not something this author anticipated. So instead, I'm replacing the references to SCP with the one from the name I bound to the location in the store. So it goes directly to the right SSH in the store using the hashed path. And then I go ahead and install the file, and we can see the listing of the inputs here. And finally, we close with some more metadata. The synopsis and description are surfaced by the Geeks interface to help users find the package when looking. So this is one of many different programming interfaces. There's an interface for defining system services that use some of the primitives of GNU Shepherd or the cron daemon, and so forth. Also, for doing batch operations on these views in the store, creating profiles automatically, creating one-off development environments. So if I ship a package, I can define what development tools I need. But how has this helped me understand the freedoms better? How does it help me realize them? Well, the first way is not technical at all. It's by having it as a stated goal of the distribution to advance users' freedom. And so this goes in the mindset trying to not just think about me as a developer, but think about what things users might like to do, both so the system works for them more or less out of the box, so that and thinking about how to chart the path of the GNU project to better meet that, but also when I haven't done it right, to set them up to do better. but also to work collaboratively. So there are some things that Guix avoids or helps users avoid potential problems that might be difficult for them to do on their own, and by creating this community space for people to work together on solving these. So two things that might be difficult is running software I wish in the context of web browsers. Where software in general is very complex. Web browsers are almost just as complex as the rest of it. But in this case, there's an example of the ungoogled Chromium package in GNU Guix. Say I wanted to run software I wish, and I wanted to use this free software browser but not send telemetry to Google. The Chromium package in Debian doesn't go to this length, but there is a ungoogled Chromium separate project, a script to modify the Chromium package. But it still takes some care to do checking to make sure that works. And so the default Chromium provided by Guix does that. Now, it might be up to the users. Maybe you want those features. Maybe you don't. But this makes it possible to go in and do that. They also have GNU's fork of Firefox, IceCat, with similar modifications. Another example is the case of bootstrapping. So this is in the context of Ken Thompson's trusting trust. How do I build a language up without a pre-existing built version of the compiler for that language, whether it be C or Haskell or various schemes? This is sort of an extension of the tracking dependencies. Eventually, if we track the dependencies back, we'll need a binary GCC, a binary glibc, binary tar, bash, auto tools, and that adds up. It can prior to recent work in GNU Guix, the binary needed to build the system were 250 megabytes. That's not auditable, and can't really answer the question: is the software doing what I want? Also, if for some reason I wanted to port it to a new architecture or rebuild only from source for whatever reason, having to hopefully find some binary that starts with doing what I want enough is not great. I might not be able to find that. But so Guix incorporates the work of bootstrappable builds such that the bootstrappable people are working on a self-hosting scheme and C compiler that can be initially run from an audible assembly seed. That's a nice project, but it helps to have it part of the distribution. So the official build of the distribution is now built using, so this is that self-hosting C and scheme compiler is GNU Mez. And because of recent work, now the bootstrap binaries in Guix incorporate that and has reduced the size of the binary bootstrap in half. So they're continuing to work, so now it's about 150 megabytes. So they're continuing to work on that, but it's nice to have part of the distribution. Right? That's something that ships on every system. And it's not this shell script that might be fragile. It uses all the Guix primitives for interacting with the store and building it in the isolated build environments. So it's easy to improve the bootstrapping chain while you're improving the rest of your distribution. How else does it help me? I think it's being able to create a new environment gives me a place to play, to try something out. When I get called on from my family for computer help, a lot of the times I don't think it's something that is actually wrong with their system, but they're just not sure what to do. And that's because they think it might break something or do something bad. This happens to me too. It just happens with my family that it happens a lot sooner. But eventually I get to some place where I don't really want to do that because it will either affect the rest of my system because of the one global state, and I don't want that, or I'm just not sure how it will turn out, or I don't really want to download all that stuff and put it in my home directory and change my dot files. I sort of liked how they were. But the tooling in Guix with the isolated environments allows me to try out the new stuff and then either roll back or just switch to a different view into that store. And this, for me, is a major win. Another thing is that the dev tooling in Guix is the same as the everyday tooling. So to build a package, I build this instructions for the Guix daemon, send it away, and it happens. To build myself a new little view into the store, I build perhaps simpler instructions, send it using the Guix tool, send it to the build daemon, the Guix daemon, and get my view into the store. It means modifying a package in Guix is 7 lines. 2 of them are comments. So this was the first free and open source software project that I have contributed to in a major way. And I think the making it easy to develop for myself and then to jump into developing for other people's made that happen. What about those 2 points about distributing software, modified and unmodified? The Guix primitives also make that easy. Guix is, in principle, a source-based distribution, like you might be familiar with from Gentoo, but also has first-class support for what Guix calls substitutes. So in building that locally on my anemic laptop, the community can run build farms. So there's one community build farm currently, but in principle there could be more. But because the source and the build instructions are store items, there's no reason that the tooling needs to treat them any differently than the binaries. So aside from a little magic that, oh, I should get the binary result instead of the source and the build instructions. But it's also nice for, I built some software on one machine and I'd like to move it around to somewhere else. Because there's this well-known scheme of how to install software in the store, I can copy store items from one computer to another. There's some more details, like they're all signed, so you can only install trustworthy binaries from a entity that you trust to sign them with their key. I can also export software for use outside of Guix. So Guix Pack supports several formats. I've chosen to show a popular one here. But I can create tarballs to run software that I have built with Guix on other systems. Should note also that because Guix lives in its own namespace in GNU Store, in addition to, like I'm using on this computer, using Guix to manage the whole system, including the kernel and the initramfs and the grub config, you can also install it as a user space package manager on top of another distribution. And what about that Debian archive tooling and publishing Debian repositories to the world that require this whole different software stack? In Guix, every installation ships with the tooling to do that. That's Guix publish and allows downloading of store items from one computer. So if I have a build farm that builds stuff and stores it in the store, using the regular Guix tooling, I can go ahead and publish that to the web in a way that Guix understands how to pull it down. We'll have another taste of Scheme. And that's right. So I have these primitives for building software on one computer and moving it to a different one. And I don't want to build stuff on my laptop because it's sort of anemic. Instead, I have a more powerful computer somewhere else and have told Guix via the script, this is the result of evaluating this is a list of machines that should automatically build stuff on and pull them back. In this case, I have one machine, so I just list it. This could do arbitrary work. It could, for instance, match on the package name and only offload really expensive packages. For instance, if I have one machine with a lot of memory, only offload package the Chromium, Firefox, to that one, and perhaps even spin it up beforehand. This is why I think Geeks is cool, but I'm not things have been built on top of these primitives. Some of the funding for Geeks comes from a European scientific computing organization, but they're working. And so if you look up Geeks HPC, you can find more information about their endeavors. But one of those projects is in scientific computing. It's common to need to run some transformation, some computing on some data, take the output of that, run it again on something else, a workflow. And so they're working on a language to use the Geeks primitives in both an executable way. I've executed my Geeks workflow, but also this is a way that we've written it down in a way that can be reproduced later. I can use the Geeks tooling to not only build the current software, but build software from a previous release of Geeks, so I can encode that in there. And the Geeks Jupyter kernel is the same way. I have a Jupyter notebook where at the beginning I describe the computing environment I need to run the rest of the notebook. And Geeks Deploy was this summer's Google Summer of Code project to, instead of using the Geeks commands locally to manipulate my local store, I can build up systems that I need and send them and deploy them to remote systems. So rather than that complex container, it's in that same space as Kubernetes. But instead of a whole separate software stack, I haven't been able to. One motivated mentor and Google Summer Code student was able to use the Geeks primitives to build up something that is in the same space and answers those questions in a different way. So thank you. There's much more to Geeks, but that's how it has improved my life, and I wanted to share it with you. I'll take questions now.
So the examples you showed, you were pulling from like other repository sources, like from like GitLab, for example.
Mm-hmm.
Geeks have its own sort of central repository you can publish to and pull to, and if so, what's the process like of getting something into that repository?
Yeah. So you're thinking like for any like.
For NPM, there's npm.js.org. For Maven, there's Maven Central. There's
Right. So for most of the software that's packaged for Geeks lives somewhere else, and so that's what goes in the package definitions. So many things are available via some mirror network, and that's encoded in Geeks. I mentioned that Geeks has this community build farm. So when that build farm fetches the code to build it locally, it also fetches the source. And it's running that Geeks publish service. And so most of the time when I download source, either to build locally or because I want to explore it on my machine, it's pulling from the store items that represent the original source that the build farm pulled down from the Geeks CI mirror server. Does that answer the question?
So there's kind of like a community server that it proxy through?
Right. It's almost like a cache.
But it seemed like that package format was really imperative, and you could sort of almost do anything in it. So how does that community server sort of deal with the complexity of that?
Yeah. So you can do any manipulation of the source. In fact, that's how the IceCat source works. Instead of having someone run a script on their computer to generate the IceCat source, which is a transformation of the Firefox source, it's encoded in the package definition. And the output of that has a hash that's not based on the content of the output, but it's known at evaluation time when the instructions are read based on the inputs and what the instructions are. So my geeks can look at what the inputs are and the instructions for getting the source and know which store item to ask for from the CI server. Right, and there's some fallback. If it's cached, it gets it. If not, then it looks at the URL in there and pulls it down. Geeks has a partnership also with Software Heritage, which is a project to create an archive of available source.
And so, like the way something would get into that community server is just because it's been asked for before.
Right, because it's been added, to, but so that one is what's in the official Geeks. So there's a Geeks repository that both contains the code for Geeks itself and all the package definitions. And when I upgrade Geeks, I just get a new version of Geeks, which is the new Geeks code and the new package definitions. There's, unlike apt or yum, there's not a separate package definition list. So this one, ci.geeks.gnu.org, the official one has the packages for that. If you had your own, if you added your own packages in your own, Geeks has a language for pulling in extra packages and extra services via a channel mechanism, essentially adding more scheme library names that we can find packages in. And those would not be present. You'd have to run your own Geeks publish instance, which if you evaluated your packages regularly would pull in the source and make them available via that mechanism. Yes?
If you do a local build of a package on your machine, is there a way to compare it with what's on the community server?
Yes.
And say, yep, that's the same?
Yep. There's a Geek subcommand, Geeks challenge. Yeah. I saw one in the back.
How do you deal with packages being built with different settings, like setting prefixes something other than user local?
It occurs to me that I should repeat the questions. So the question was, does Geeks deal with modified packages that have a different prefix or different configuration flags? Right now, not. You get a separate. It gets a separate store location with a separate hash. There's no out of the box. There's no parameterized packages like you might see or use flags in Gentoo. I think in Geeks, the discussion on the mailing list calls them parameterized packages. The experience isn't that great. It depends. If it's a leaf package, in my package definition, instead of repeating everything, I can use scheme just to manipulate and change the values I want. And there's some command line UI for if I wanted to change an input for a package. But the problem with this, with the tracking all the dependencies, if it's not a leaf package, then everything that used that, its input would have changed and will have to be rebuilt. So that's, it trades that flexibility for increased computation and time. You can build the whole Geeks to not use GNU Store, to use a different location, but then you can't use any of the community-built packages because they all have all the paths encoded in them. Sure.
So I get why you would use this for managing sort of like system dependencies, but you were originally mentioning kind of like Ruby gems and NPM and things like that. Would you use this to manage dependencies for an application?
It depends on the application. So we'll start with the drawback. The problem with Geeks, but I think any system like this, is that you need to encode the world. So the question was, would you use this for managing an application, the top layer of your software instead of the bottom layer system dependencies? So the problem with Geeks or any system like this is you have to encode the world in Geeks so then you can manipulate it with the Geeks features. In the case of our Ruby apps at work, we can't. The dependencies are too numerous. I have used it for giving me just works-like functionality for the parts that NPM or Ruby gems wouldn't handle well. So that 3D modeling application I mentioned uses Blender to do some of the transformations along with a Python plugin. Yeah, and it's really nice to be able to use Guix as a user space package manager on top of my thing. So Guix is not the only distribution that uses this model of the store and tracking dependencies. The other one is Nix, N-I-X, nixos.org. I talked about the free software principles, and Guix wants to build everything from source. Nix has a different community aspect to it. So a lot of the same things, but they have a different language that's not a general purpose programming language that's specific to that. But one of the other things that is different is they're more willing to add binary seeds. So Guix has essentially no JavaScript packages because the base of the JavaScript build tooling is not buildable from source, especially all the dev dependencies and test. But Nix is willing to import the binaries, and so has much better coverage of NPM. A lot of the packages, a separate thing that might make encoding software in Guix easier is that most packages don't require custom fixes to get them to build, and so the build recipes can be produced automatically. So both Guix and Nix have, quote, importers, and so if I'm able to have the base dependencies in, point an importer at npm or pypy, and automatically create package definitions, which are probably not up to the quality of distributing a part of the distribution, but for a local software that I know has this list of dependencies and I want to manage it with Guix or Nix for whatever reason, I could do that. OK, is there anything else? Anything you'd like to see? We can tempt the demo. I don't have a demo plan, but I do. Obviously, I have a shell on the system. So if there's something different you want to see, I can show it. I will. Oops. I will remember how to use my computer. So what I will show I'll show the recipe or the instructions I have for Guix for producing my little view of the world that I use for my daily software. It may not actually conform to the best practice, and we'll talk about that in a minute.
Are you using the actual Guix operating system, or are you just using the package manager on top of another operating system?
So here I'm using the Guix system distribution, so for the whole thing. I'll make this bigger in a second. So of course I've captured all the whole operating system configurations. And my user space thing in a Git repository. So some boilerplate. I'm going to be manipulating some modules, and so I have to import them all. So here I'm just creating a list of strings that correspond to package names I want in my view of the world, and I have some scheme for doing this. So this may not be the best practice anymore. It depends on what you mean by best practice, but there's been some recent work by some people in Guix to support this is great, but this is now I'm getting back into that one big view, but to encourage users and help users to instead slice up their view for different tasks that they do and only load some of them on demand. It makes it quicker to build. Building that profile on my laptop is actually quite slow because it has to go through and figure out the symlinks. The disk in here is really slow. But if I don't need all this sound stuff, but once a month, why have that polluting my environment all the time? But it's a long list.
What was the triple semicolon?
So in Scheme and other Lisps, semicolon is a comment character, and the triple semicolon was, so it is more, the extra ones are for users, not for the computer. So it's for me because I wasn't sure about that stuff and I wanted to find it again and perhaps take it out. And just remind myself of like, I should clean this up. So I had this big long list. And then I have this thing. So I was doing some graphics work at some point, and I got tired of faulting in the font I wanted to use. I just wanted to be able to look at them all and like flip through them and say like, which one do I like the best here? So I decided, well, I have plenty of disk space. Why don't I just install all the font packages in Guix? Rather than statically create this list, I'm using the programming interface to do a regular expression match against the package names, which by convention start font dash, and get them all. So when a new font is added to Guix, and I tell it that I want my view of the world built again using the new Guix, it will add that. So my font list never grows stale. The other thing I'm doing in here is I've put a package definition. I can in this file. Why have I done this? There was a bug in the newer version of Alpine that crashed when it talked to my Works SMTP server. But I'm able to hold just this one package back. And it still gets built against the newer SSL libraries. So that's nice. So here I have just pulled in the whole package definition wholesale, and that's why there's so many dependencies. And then so how this thing works is it returns a manifest object, and that's a language for that view into the store. When I did in the demo, the view that had Emacs, Cause, and hello, it created a manifest and built that. So the way a lot of these programming interfaces work is just the last thing it returns. Guix expects a certain type of object. So I can do arbitrary scheme work as long as the last statement returns that. And so this last thing returns a manifest that's based on the specs and that font and Alpine that I created in here. The other thing that is interesting, I'll do that one. So this is the scheme thing that defines what my operating system config is. So in the same way, I just need to, at the end, return an operating system object. So the rest of this builds an operating system object with host name and bootloader config. Have my disk scheme in there. User accounts are managed in there, and so extra packages. Services I want running. I've created this custom service for adding UDEV rules because the UDEV rules for my second factor token are not present, also for my scanners. But I can just pick extra packages. And so rather than have the distribution have to ship everything under the world that might cause problems under some circumstances, so there's, oops. There's a default list of services, but in my case, that wasn't appropriate for my machine, so I've added some. You can filter. So this is just a scheme list. So you can filter and remove them, etc. So that's the demo. Sure.
When's the inevitable Parke geeks going to be ready? Because surely someone rewriting all of this is Python, right?
Not that I know of. So the Nix one is in their own language. So Nix is very popular with Haskellers, and there's a re-implementation of the Nix language, which is Perl and Shell spaghetti, in Haskell, which is sort of interesting. This doesn't answer your question about if someone is going to rewrite Geeks in Python. But in some ways, Scheme isn't that far off from Python. In some ways, it is. But various core components, I think glibc in the latest versions depends on Python for some of the build tooling, or at least the tests. But add for Guile, the Scheme language is not the only language the Guile system supports. It also supports Emacs, Lisp, maybe JavaScript, but also there are people working on at least running enough Python to build the glibc tests on top of Guile. So once you bootstrap Guile, then you don't have to worry about bootstrapping glibc so that you can build Python to build glibc. All right, so I think I'm at time, but sorry. But I'll be around. Thank you.